This lecture is not so much of a Bible study as it is just a presentation of some scientific data that is points to the glory of God in the end of it. So I'm going to start with a math lesson, and don't try to leave. I locked the door. But we're going to start with just basic probability. And, this talk is called What Are the Odds? Probabilities, essentially all I am really discussing. If I can get this thing to click. There we go. Okay. So probabilities work like dice. You have a six-sided die here. I will make these easier to see, don't worry. You have a six-sided die here. There are six different things that can roll on this die when I roll it. I rolled a 2. The odds of me rolling that 2 were 1 out of 6. We represent that with division. 1 divided by 6 is a small number, less than 1. If you were trying to calculate probabilities that happen sequentially, meaning I just rolled a 2, what are the odds I roll another 2? It's again 1 in 6, but it's not independent. They are multiplied next to each other. So 1 over 6 times 1 over 6 is 1 over 36. That's about 0.0278. That's 2.78%. Small chance that I roll 2 2s in a row. And that only increases if you increase the sides of the die. So here's a 10-sided die. Again, it's 1 over 10 times 1 over 10. 1 over 100, a 1% chance. You can go as far up as you want with this. The biggest one I have here is a D20. 1 over 20, 1 over 20, 1 over 400, 0.25% chance. It's a very small probability, we would all agree. However, I've played games with these dice, and I have seen it multiple times where 2 numbers get rolled the same in a row. So even though it's only a 2.25% chance, it's likely to still happen, if you roll it enough times. So it raises the question that how small does this have to be before we consider something impossible when it's never going to happen? If you asked physicists, they'll tell you, well, there's always a chance for anything. Statisticians will always say, as long as there's a chance, something can happen. But there is a number that is conventionally thought of as being so small that it's never going to occur. Did I have it here? Right. Yeah. So statistically impossible we consider to be 1 over 1 times 10 raised to the 50. And this is 0.47 zeros, 1% chance of happening. That is so small, like 10 raised to the 50. If you converted that to seconds, that is in time, like longer than the lifespan of the known universe. It is multiple hundreds of millions of years, however long you want to consider the universe being in existence. So think of like a chance something happens every second and waiting a billion years and it never happening. That's what we're talking about here. Okay, so the start of this talk is going to be about what are the odds that the Earth as we know it got formed. I'm going to be using arguments made in scientific theories for evolution and the Big Bang. Now, evolution, there's no qualitative or quantitative evidence for the transition of one species to another. There are things called microevolutions. We call them adaptations. You look at a canary in one region where they're designed to eat nuts, they're going to have a different beak than a canary in a different region that is designed to eat nuts, bugs. Mm-hmm. Yeah. So that is an adaptation. We can observe that even in our lifetime. We can observe these adaptations happening. Macroevolution is the transition of one species to another. It is that bird turning into a lizard or vice versa. There's no fossil record evidence of this, and it is, at the end of the day, just a theory because no one can prove it. So I am still going to be using the arguments of the theory of evolution and the theory of the Big Bang. Now, the Big Bang's a bit more credible. And when in Genesis, when God said, "Let there be light," I do believe that there is an explosive outcome from the Word of God, directly from His mouth. So if you want to argue time-wise or whatever, I personally do not believe theologically the idea of an explosion causing our universe interferes with my Christianity. God is God. He always will be, and anything that he does is going to be on a monumental scale. So just him speaking, it's a pretty big explosion. The main evidence for this is that from our place on Earth, we can look around at galaxies and universes, and everything is sort of moving generally very slowly from a central location. So the idea is that there was a long time ago, big explosion, everything moved out, now it's moving very slow. But I'm going to be presenting this thing called the rare Earth hypothesis, because we can see a really long ways into the universe. And there's a lot of stars and a whole lot of planets. And by our best calculations, there should be tons and tons of Earths. There should be lots of places where life has developed. But we haven't seen it. We haven't found it, and we haven't detected it. And it's what's known as the Fermi paradox, that statistically, you would think, from what we can observe, there should be more Earths. But there's not. And this rare Earth hypothesis is a series of explanations to say why we're probably a one and only here. This is probably a unique situation we found ourselves in. So we're going to start with what is known as the habitable zone. There are several factors that have to go into an Earth being Earth. I'm going to go through them. They are the habitable zone, stable orbit, correct arrangement of planets, a right-sized planet, plate tectonics, a large moon, an atmosphere, an evolutionary trigger, and a disaster-free time period. But this is the first step. Much of the known universe, including parts of our galaxy, are what's called dead zones, unable to support complex life. Those parts of the galaxy where complex life is possible is called a habitable zone. This is primarily characterized by distance from a star. So if you look right here, I think this one is what they designated as Earth, but this area right here, we would conservatively believe an Earth could hold and sustain water. Water is very, very important because in the theory of evolution, all life sprang from water, called the primordial soup. Single cells into multi-cells, into animals, into plants, and everything. So the whole basis of the theory of evolution constitutes that the Earth has to be in a situation that will support a primordial soup. It will support water in general. Water is very rare in the universe, as it turns out. Too close to the sun, you're going to get irradiated. You're going to get burnt up. Too far away means there's not enough metals in the atmosphere or in the stars to form terrestrial planets. And if you're closer, more dense, gravity is a function of the mass of an object. So if you're very close to very massive stars, it's going to pull you in and blow you up. And that's not good. And the final thing that needs to be happening in this habitable zone is, I'm about to move on to it, what's known as a stable orbit. You need to have a nearly circular orbit around your sun. If you don't, let's say you're an elliptical orbit, like an oval, there's going to be times of the years where you pass a little bit too close and you catch on fire, and times of the years where you pass too far and you freeze over. Oh, did I already click that? Oh, cool. Wait a minute.
I think you skipped one.
Yep. No, I'm going too far. There we go. Okay, here. So, sun-like stars, habitable region is very average, circular orbits. Hotter stars have a larger area, but also you're too far away. And cooler stars have a smaller area, and you're too close. It's normally not going to cause an circular orbit. Because in the elliptical orbit, like I said, you'll get burned up or cooled down, but also, oh, dang it. This just goes, okay, I got a lot of sciencey stuff here. Okay. Let me scroll my notes, and now we're back to this. Okay. If you were too close to your star, you're going to be in what's called a fixed orbit, meaning that as the sun, as your Earth is going around it, it is not spinning. One face is only facing it the whole time. So that one face is going to get burnt to a crisp, and the other side is going to get iced. All of these situations serve to either evaporate or freeze the water that we need for evolution, so it doesn't work. The next thing we're going to talk about is we need, come on, click. There we go. We need the correct planets. Our solar system is something you learn in your first grade science classes, but we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. particularly of importance is Jupiter and Saturn. If you notice something about these two, they're really big. Comparatively to Earth, they are massive. These gas giants, let's see. Jupiter is a gas giant and has 2.5 times the mass of all the other planets in our solar system combined. What I mentioned earlier about mass controlling gravity. In essence, the more mass you have, the stronger you're going to pull on objects. That's why our sun is pulling all our planets around us, and that's why we're in these orbits. So these big bad boys act like space vacuum cleaners. All the time through space, there's rocks flying, meteorites, big boulders, asteroids. And all the time, these boys are on our outer orbit, just pulling them in.
Wow.
They get hit a lot, and they just act as a natural shield to the Earth that provides protection, essentially. Like I said, primordial soup's got to be safe. If you have an asteroid hit the Earth, even one the size of like a sedan, it's going to cause extinction level events. It's gonna wipe you out.
Wow.
So we need these. We need these. And if you look, you can actually see that Earth and Venus are very, very similar. Venus is called our sister planet. But you'll notice something about Venus. It's basically just a rock because it's just a little bit closer to the sun. Just a little bit too close. Let me see. Did I already pass the... Yeah. So this is something that's called, we use it a few times, the Goldilocks principle. With the orbit and with the habitable zone, you can't be too far, you can't be too close, but you got to be just right. So Earth is a Goldilocks type planet. And another Goldilocks principle comes into the size of the planet. Earth, here, Mars, the smallest conceivable habitable world, 0.028 of Earth's mass. You get too small, you get basically just moons. But a planet that is too small cannot form an atmosphere for itself, rendering its surface temperature low and a variable ocean that we need impossible. Excuse me. A small planet also tends to have very deep canyons, rough, huge canyons and huge mountains, which break up large sections of the planet. The core cools faster, and plate tectonics are virtually non-existent. I'll get to plate tectonics here in a second. Although if the planet is too large, it will retain too dense an atmosphere, like Venus. So like I was just saying, Venus is our sister planet, right? It's just a little bit different than Earth. However, because of its size, the surface atmospheric pressure is 92 times that of Earth. What does that mean? Pressure changes with temperature, or temperature changes with pressure, I should say. That means the surface of Venus is about 863 degrees Fahrenheit.
Wow.
Can't support water. So cosmically, Venus is so close to Earth because planets and stars are huge variations in size. But even that small difference puts it outside of the range of the Goldilocks principle. Next thing I'm going to talk about was the plate tectonics. So Earth, if you don't know, if you were to look at it stripped away, it looks like a cracked eggshell. It looks like someone took it and just crunched it, and all these cracks huge formed along it. These are our plate tectonics. They are continents that are made of a less dense rock that floats on the magma of the Earth. Let me get my clicker, scroll my notes. When these meet, they push down and push up. They form mountains. They form huge trenches. They form ridges. You can look at the graph, but the lack of mountain chains anywhere else in the solar system, when we look at other planets, we don't see mountains like we see mountains on Earth. It's evidence that Earth is very rare in terms of its plate tectonics. These tectonics are not something that other planets have. They're either solid or cracked very thinly, but not like ours. There's also evidence to believe that these plate tectonics moving are what allow for oceans to be possible in the first place. So once again, going back to the idea that we need them to form our primordial soup. Now, the next thing is our moon. If I will click. There we go. The main theory for how the moon was even formed was that at the creation of the Earth is sitting there, a huge rock came in and hit us, spun off, and all of its excess began to orbit the Earth because Earth is pretty massive, formed together, have the moon, and there we got the Earth. It's also equal to note that if this didn't happen, the Earth would not have probably cracked properly to form our plate tectonics. So, pretty fantastic. It is also the main theory that put Earth on an axial tilt. So relative to the sun, Earth is not straight up and down. It's tilted at a certain degrees. The axial tilt is another Goldilocks principle. Can't be too far, can't be too upright. A planet with a large tilt will experience extreme seasonal variations, too hot and too cold, literally, Goldilocks. And a planet with little to no of it does not contain the environmental stimulus that is currently believed to need to produce evolution. In addition, having a satellite around our planet, that's just an astro term. Anything that orbits anything else is a satellite. We think of satellite as metal configuration in space, beaming lasers. The moon is a satellite to the Earth. A large satellite increases the likelihood of plate tectonics through the effect of tidal forces. We all know the moon pushes in and out on the water. The impact to form the moon may have also initiated the plate tectonics, like I said, without which the continental crust would cover the entire planet, leaving no room for oceanic crust. Our water would be still and dying. But then after the Earth gets bombarded with the moon, it's got to be able to develop some protection from the sun, and that is our atmosphere. So without an atmosphere, even in our Goldilocks state, away from the sun, we would get burned up by UV and gamma radiation. The atmosphere acts like a net. It catches it. It protects us. You stay out long enough to still get sunburned, but it's better than staying out a little bit too long and dying immediately. Nitrogen and carbon dioxide are needed in a correct ratio to form life, very specific. Lightning in general is needed for nitrogen fixation. The gaseous carbon dioxide needed for life comes from sources of volcanoes and geysers. Without our tectonic plates pushing up against each other, we don't get those geysers, we don't get the primordial soup activated, we don't get evolution. Carbon dioxide is also preferably needed at relatively low levels, because at high levels it's poisonous. You've heard of carbon monoxide poisoning. It's, you sit in you get yourself trapped into a garage with a car running, you're going to die because all the oxygen is getting burned away. You're left only with carbon dioxide. And also the atmosphere is the only thing that produces a rain cycle. So without it, we get no rain. We get no clean water, I should say. All right? Almost at the end of these necessary requirements. The last thing is probably the most contentious aspect of the evolutionary theory because it is the process of evolution. So the theory is that in the primordial soup, there are these things called prokaryotes. These are, over here, proto-eukaryotes. Single-celled, very simple as you can get organisms. They don't do anything but live and die and reproduce themselves. What you need for evolution is a jump between a prokaryote and a eukaryote. These are the animal and plant cells that you would have learned about in middle school. The key for this is the mitochondria, the powerhouse of the cell. The transition between prokaryote and eukaryote is a many thousands times energy deficit. To go even from this simple one cell to this more complex multi-cell takes much more energy than the prokaryote is capable of producing. So there has to be an outside stimulus that provides the prokaryote the energy it needs to evolve into something more. And there's a lot of different theories as to how this happened. This is just one of them. that the prokaryote absorbed another single-celled bacteria. The single-celled bacteria stayed in there long enough that it developed into the mitochondria. The mitochondria then was able to fuel the further evolutionary processes. And when I say there's all sorts of theories, this is one. There's one that the water got struck by lightning, and the lightning provided the energy. There's one that it just happened happened one time. And if you believe the theory of evolution, you have to believe that it only happened once, because all cells, animal, plant, all eukaryotes, have a common prokaryote ancestor. So that means that one time during the 4 billion years of prokaryote development, a single mitochondria was formed, and all of the rest of the planet came from this one cell. You have to have a very safe environment for that to happen. All these factors would have to line up. That one cell would have to be completely successful. And then you have to give it a long enough time to develop from that one cell it just so happened to develop into all the other species, intelligent life. There is no scientific reason that we can think of that anything would develop sexual reproduction as a means of reproduction. In terms of energy cost, if you were a single cell trying to evolve, trying to make more of yourself, it is the best efficiency to split yourself, and then asexual reproduction, split those again. Sexual reproduction requires two partners to successfully reproduce at least twice, even to get back to what we started with. It is, no one really understands why that would develop, put it that way. So, on to the very last point of this is the disaster-free time period, like I've been saying. These single cells would have to be in the soup, in the earth that is in the Goldilocks zone, is in the Goldilocks orbit, is in the Goldilocks tilt, with a gas giant protecting us, with a moon orbiting us, and it would have to avoid any natural disasters for about 80 million years. And we can't even seem to go 5 without something going horribly wrong. So this all culminates into what is known as the rare earth formula. And it's very simple in terms of scientific formulas. I've seen some nastier ones before. But it just breaks down all these things I've talked about and puts them as a variable. Habitable zone, stable orbit, arrangement, planet, tectonics, a moon, an atmosphere, evolutionary trigger, and disaster-free time period. FH, FO, FP, FR, FT, all those represented here. And like I did before with our ratios, these are represented as a chance it might happen. The odds that a planet in a stable solar system has a stable orbit, the odds that it has the correct arrangement, the odds that it has the right size planet. And you multiply all those odds together against the number of Earths that would have evolved intelligent life, or that is N. That's what we're finding. How many Earths exist that would evolve intelligent life? So we take the number of stars in the Milky Way, just because that's our observable one. It's the best ratio we have. And we multiply it by the number of planets in the habitable zone. This is something like 10 to the 15 planet. It's a lot. It's a lot, even in the Milky Way. No, it's 10 to... These two numbers multiplied together reach about 10 to the 10. So a very large number. Most of these ratios cannot be properly averaged, because in order to make an average, you need more than one data point. We only have one data point, and it's us. That being said, the best estimates that scientists have put together that support this theory break down this formula to coming out to somewhere between 0 and 1 Earths. So in our universe, between 0 and 1 Earths got formed. And we're on it. We made it. So,
And we're the intelligent ones?
Yes, we are. Yeah. To say, I often think, looking at numbers like this, that it will take more faith to believe in an atheistic point of view than it does to believe in a godly one.
Right.
Because we believe in the Word, the Bible that was written, inspired divinely by God. I work in the scientific field. There are a lot of people who really know what they're doing. There are a lot of people who don't. Both publish papers. You have to put your faith as a scientist, because there's no way a single person can study all of science. You have to be able to put your faith not in God then, but in other people.
Yes.
Other people are imperfect. So we made it. We're on the singular earth. But now those chances are crazy. I want to consider now the chances that this succeeded. Okay? We're here. Now that we're here and we're established and humans are living and roaming on Earth, what are the odds that you, as a person, exist? Does anyone want to guess?
Between 0 and 1?
No. So, would you say you're 1 in a million? Do y'all think that's too much? More?
I've always thought he was.
Yeah.
1 in a zillion.
Is there a zillion number?
So, we're going to just walk through this. And this, by the way, is not arguable science. This is direct analysis of simple statistics. So what are the odds of your parents meeting? Let's see. The odds that your parents meet, the average 25-year-old person will meet about 10,000 people in their lifetime of the opposite gender. So 2 people, 10,000 each. That is a 1 in 20,000 that your parents meet. It's a 0.005% chance. Okay? Now, what are the chances that once you meet, you get married, you have kids? It's actually less, 1 in 2,000, 0.05% chance. Now, a quick biology lesson before we go to the next point. When a sperm and an egg meet in sexual reproduction, they string up their DNA together, half from the father, half from the mother. This stringing up of the DNA is 99.9% common between everybody. Everybody in this room shares 99.9% of their DNA. That 0.1% holds every single variation in your body. Your height, your hair, your eye color, your skin color, everything. Your sex. So, it's a very complex stringing up. So what are the odds that your mom's DNA strung up on your dad's DNA in the exact way to make you? And that one is 1 over, it's 100,000, million, billion, trillion, I forget the last, quadrillion. Yes. Oh, dang it, I didn't want to go that far yet. Come back. Okay. So you specifically, that is 1 in that. Yeah. I should also say that before we started this, the odds of you being combined just from your parents' meeting was 1 in 40 million. Right? So keep that in mind as we continue about how statistics have worked, how we calculate this stuff. Now that's a big number. What are the odds now that all the generations that came before you lined up, met, had children, those children were passed the exact genes that were passed to your exact parents, to grandparents, great-grandparents, etc., down the line, to end up giving your parents the DNA, even the chance to make you? And we're looking at that one. We will now move on. If I will click. There we go. So, ancestors meeting, 1 over 1 times 10 raised to 45,000.
Wow.
That's the chances of all your ancestors meeting, just meeting, for you to line up where you are. That is 1 over 10, then 45,000 more zeros after the 10.
Oh my gosh.
I can't fit it on the screen. Okay? Now they've all met. Now what are the odds that after they all met, they all got the right DNA to pass down the chain? And that one is 1 and 1 times 10 raised to 2,640,000. That is 10, and then 2,640 more zeros after that. I cannot fit on that screen either. Okay? Now remember what I said about how consequential ratios have to be multiplied together. So we end it getting up to, after they're all multiplied together, 1 in 1 times 10 raised to 2,685,000. Remember, we started with impossible, which was 1 over 1 times 10 raised to the 50. That means that you, sitting here today, existing, is 53,700 times more impossible than impossible. All of you.
That is amazing.
God tells us that He knows the number of hairs on our head, that He knows the plans He has set out for us. It is hard to disagree with that when you look at just the odds that you're even here today, much less the odds that you'll get to where you need to be going.
Wow.
There's no real end to the talk. This is it. There's this common video I keep seeing circulating on social media, and it's people walking up with a microphone to random people on the street, and they say, "Hey, I'm going to give you $10 million. Will you take the $10 million?" And they'll say, Of course I take the $10 million. And they say, the catch is, tomorrow you won't wake up. And they'll say, "No, I don't want the $10 million anymore." So what that statement alone means is that to most everyone who would agree with them, tomorrow is worth more to you than $10 million. You're a miracle here walking on earth, and you're given a very finite amount of time in a cosmic sense. It's impossible, many times more impossible than impossible, that you're here. So try to make it count.
Wow.
That's good.
And that's
Thank
So, questions, comments? We talked after the Monday group for 20 or 30 minutes just about stuff. If anyone's got anything, I'll be happy to try and answer. Yeah.
So it seems like the evolution story and the Big Bang story are both just telling their own version of creation, right?
Yes.
The Big Bang has a singularity that just was and always was, right? And then, as you said, the proto cell happened once, right? And it just did. And so, I mean, that seems like even more evidence for God, that they're doing the best they can to describe the origin of the universe without Him, but it all starts with a point that just was there.
Yeah. There is a famous quantum physicist. Quantum physics, if anyone doesn't know, is a relatively new branch of physics. It just came out maybe the past 50, 60 years. It's really been developed. Kind of started with Einstein. I had the quote here at one point. Let me see if it's still right there. Yeah. So Werner Heisenberg is a very famous fundamental quantum physicist. And he's a Nobel Prize winner multiple times, and he's quoted as saying that the first gulp from the glass of natural sciences, studying them, will turn you into an atheist. But when you get to the bottom of the cup, God will be waiting for you.
That's good.
What I was saying about physics being a fundamental science, in your 101 physics classes, you will run into questions that you don't have an answer for. And no matter how deep you dig, it's still up in the air sometimes. So anytime you work one of these theories back to the very beginning, there is a we don't know yet point. And I don't know how long we could continue studying, I think, forever, and we'll never get to the bottom of it. There's always something smaller or bigger to find out.
Well, but in that case, it's not even a matter of knowing, right? They're trying to create a theory.
Yeah.
And the best they can do is another version of creation. I
Yeah.
mean, there's no other idea.
Yeah, and even in science, when you hear the word theory, they can be pretty solidly developed, but just not be perfected. Gravity is a theory. I don't suggest you test it by jumping off with an umbrella, but yeah, some are more concrete than others. I do have some numbers here. I guess some last ones I could read. Hold on. Nope, it's already gone away. Okay, that's fine. So, 10 raised to the 2 million. Try to give you some perspective for how big that number is. 10 raised to 27 is the number of atoms that make up the average human body. It's a lot.
Wow.
10 raised to the 50 is the number of atoms making up the entire Earth. 10 raised to the 80 is the number of atoms in the known universe.
Wow.
So 10 raised to the 2 million is an unfathomably large number. The odds of that event happening are the same as this one. You could take 2 million people, this population of San Francisco, hand each one of them a dice with 1 trillion sides on it. Million, billion, trillion.
Yeah.
1 trillion sides on it. All 2 million of those people have to roll their trillion-sided die, and all of them have to land on the same number to equal the odds of you existing.
Wow. Statistically impossible.
Mhm.
Gee.
The
I
only
always felt that quantum mechanics, which can explain things that classical physics cannot, and I had to use it quite often
yeah.
to predict outcomes that I would get from an experiment.
Mhm.
And that really made me a believer in God,
Mhm.
because we just couldn't understand it.
Yeah. I'm not great at math. If you wonder if you have to be good at math to be a physicist, you don't. You have to be very stubborn. Quantum mechanics as a class of math, this is going to sound like something I'm pulling out of sci-fi. It operates in a dimension higher than we can perceive. So, hey, is this a whiteboard?
Mhm.
Yeah. Okay. So this board is 2 dimensions, right? You have the X and the Y, right? It can only, this board and this drawing only exist going left and right, up and down, or at a diagonal, right? If I want to think about 3rd dimension, I can kind of think about this Z coming out of the page. So we live in 3 dimensions. We think of things as rounded or circular. Quantum mechanics, the math, is done in 4 dimensions because it includes time. So we have not only our position, but also our position in space, but our position in time. So you have to learn, like every physicist can do quantum mechanics, but if any of them say they understand it, you're being lied to.
And the Heisenberg uncertainty principle.
It's just that. It's that you can know the position of an
but
object.
not at that time.
You can know its position, you can know where it is physically, or you can know when it's going to get there, but you can't know both.
Yeah. It'll move by the time.
Yes.
Yep.
Is there a part to that, when you measure something, you change it also?
You do. So this analogy I like to use, quantum mechanics is most commonly thought of in terms of light. Light is a very complex thing. It's very hard to define. It acts as a wave, like sound, traveling through the air, and it also acts like a particle with mass at different times. Light is made up of photons, nearly massless. It is the lightest thing that we know in the universe. When we see something, light is bouncing off them and going into our eyes, and our eyes are visualizing it. Anytime we want to see anything, we are shooting photons at it. Those things are bouncing off and coming back to us. So how do we try to see light? The only way we can physically do it is throw other photons at it. If I had a bowling ball here, and I sat here and I threw ping pong balls, they'd just bounce off, right? But if I threw another bowling ball, it's going to move it. So when you measure things quantum mechanically, you inherently affect them. You move them. It develops this whole philosophy that just by existing, you're changing the universe around you, and that's a whole nother can of worms. But yeah, it's hard to measure things in quantum mechanics, and it's a branch of science that everybody right now is working on, and it's not going anywhere very fast.
Many of the early scientists were believers,
Mm-hmm. Yes.
and we've gotten kind of totally away from that.
Yeah. There's
And based on this that you're talking about, it almost sounds like a fool's errand to try to prove the kind of things that you were talking about early on.
Mm-hmm. And we talked about this in the Monday morning group briefly, that I see physics as just a way to study the playground I've been put in. I get to look around and try to observe and figure out how God may have, in his infinite power, performed some of the actions he did. Not that I think I'll ever succeed in that, but I think it'd be fun to try. There is this inherent atheism that comes with science and scientists, and I think it stems primarily from people's sin nature. People are inherently sinful. They're born with a guilt nature.
Yeah.
So you can either reconcile with that guilt, admit that you're a sinner, and come back to Christ, or you can prove it doesn't exist, and if God doesn't exist, then there's no one to be guilty to, and I can do whatever I want.
Interesting.
Yeah,
Yeah.
So
That makes sense.
most atheists and scientists will desperately pursue the latter
Wow.
because it will absolve them.
Wow.
but it wasn't always that way, right? So the study of physics came out of what you said, that the way you study it. It came out of theology.
Yeah, and
It came
like
out of studying the heavens.
in older times, it was often reversed. Scientists would bring these new findings, and the church would say, heresy. Galileo said, we're not the center of the universe. We have a sun. We orbit around it. And they burned him.
Yeah.
Hmm.
So it has done sort of a flip-flop.
Do you see any evidence of a shift in people where they're more willing to behold the face of God? You had mentioned something about change you're receiving at the university with
Mhm.
students and things of that sort.
Yeah.
Is that translating into these natural sciences as well?
At the very least, I think in general more people are saying I don't know rather than I know there isn't. My advisor at school, this was just complete happenstance, Dr. Abate, he's a Christian. He was raised a Christian. He's from Ethiopia. Most of the people in the department, at least the ones I discuss with, wouldn't say they're outright atheistic or they know there isn't a God. It's that they don't know. Because I'm telling you, you get to studying some of those late term physics classes and you'll look for God. I mean, it's not fun.
You'll be praying, huh?
Mhm.
When you were talking about those astronomical figures, I heard a pastor teaching recently, and he said if you believe that all of that what we have just happened, it would make as much sense as if I took my pocket watch and disassembled it, put it in my pocket, and shook my pocket until I had a watch put back together.
Mhm.
I mean, it's just that.
It's complete chance and statistically shouldn't happen. Of course, the argument that will be brought up is that given enough time, it could. But also, if you ran that impossibility statistic through the time of even the oldest estimates of the known universe, you're never going to hit on a averaged 1. You're never going to hit a chance that it happened.
Yeah.
And that was just the random 1 over 50. This idea that you exist is
Wow.
more than impossible.
That's amazing.
So if I look at Ron and I say, you're impossible,
Mhm.
then that's just true. It's a compliment.
Yeah.
I should feel good.
You're
I should
spitting
feel good about
facts.
it.
That's fact.
Sound like, thanks, honey.
And one time, again with UGA people, they had speakers come in and they argued this concept of irreducible complexity. And, you know, and talking about the eye and how complex it is and how difficult that would be to put together. And then you got the nose and you got the feet and all these parts that are irreducibly complex. And then putting them together as irreducibly complex. It seems to be kind of the same thing, you know, that you're talking about, just in a different kind of way. But the people who were arguing against it were saying, but, you know, the kind of the statistical, if you do this enough, and if you do this enough,
a million monkeys with a million typewriters will eventually reproduce Shakespeare.
Yeah.
It's the idea.
I've heard
Just keep typing. But I didn't even really touch in depth on, there was, one slide about evolution, because that is a whole another lecture, 10 lectures in and of itself. And I didn't do the rare earth theory hypothesis justice. This is just, a 30-minute breakdown of the main ideas. There's a lot more number crunching that could be done to prove it even further. And I just like ending with the genome, the DNA, because it's established. We know DNA, we know how it works, and we know relatively, even if just back through the history of humanity, recorded history of humanity, the odds that it breaks down to make you are astronomical.
Wow. Wow.
Yeah.
Adam, more than 30 years ago, I read, I can't remember exactly which one it was. It was either Francis Bacon or Sir Isaac Newton. Said exactly what you said, or it was very similar to what you said a while ago, that his approach was God had made a wonderful universe, and it was his privilege to explore it.
Yeah.
And see how God had done what he had done.
Yeah.
I'm kind of fascinated. You said, and I heard it again Monday, I'm taking notes tonight. But I'm so fascinated. That we have 99% the same DNA, and all that difference is in the 1%.
99.9. Yeah.
Is that what we said?
99.9%.
That was what I read. I hope I quoted it correct, but yes, it's close.
I confess I'm an ID channel fan. I watch a lot of these things about solving murders, and it's always interesting when, the DNA evidence said it was you, there's only a 1 in 6 billion chance it was anybody else,
Right.
And all that comes from the, what, 1%?
Yeah,
1/10 of 1%?
Yeah.
Yes. Yeah. It is amazing.
Now, to be fair, we also share like 60 or 80% DNA with potatoes, or something like that.
Have you ever thought
Good
about
to know.
most of the world's problems that exist today are arguing over that 1/10 of 1%, right?
Yeah. Yes.
Yeah.
And that's on us.
Yeah.
I can't figure that out, but I can figure the other part out.
So I think it's important to point out the dishonesty of the randomness argument when it comes up. You mentioned the 100 monkeys and the typewriters, and eventually they would type Shakespeare. But you would have all the tons and tons of nonsense to look at.
Yes.
Right? So if things form from randomness, where is all that nonsense?
Yeah. It's, the general populace, and I'm not trying to say this like, oh, I'm a scientist, but believe what the leaders in the field say. And so if the leaders in the field come out and say, this is how we were made, 80%, 90% of people will be like, okay, cool, that's what the leaders said. That's what the scientists are saying. Very few are going to research it into it heavily, and even fewer are going to understand it to a point where they're going to say, can you explain some of this? But those people, whoever's in the top of the field, so long as they want to get across a certain message, they will. And a lot of people will think of, in scientific communities, pointing to creationism as sort of throwing your hands up and throwing in the towel. It's like, I give up. I can't figure it out anymore.
Well, but see, the funny thing is, that's what the Big Bang Theory is. There's this Big Bang.
There's always contention with any theory. That's why they're theories. There's only like 3 laws in all of physics. Like there's only like 3 things that could be proven, and one of them is that when I push this, it moves.
What are the other 2?
So there's Newton's first, second, and third law. That one is the second one, but it's, objects in motion stay in motion. It is the, and I'm trying to figure out how to say them in not formulas. Objects in motion stay in motion. Equal opposite reaction. And that's the conservation of momentum. I can't remember the third one right now. Sorry. That's like a 101 question.
Well, speaking of genetics, didn't you say your little brother's a biologist?
Well, Eli is studying medicine right now. I think he wants to be a pediatrician. Yeah.
Is objects at rest stay at rest, is that the effect on it?
Objects in rest tend to stay at rest unless acted on by an outside force.
Equal to the mass of the force acting on an object is equal to the mass of that object times its acceleration.
That's what I was trying to say. The second law. It's F equals ma, but I didn't know how to put it in words.
That's funny.
That is, I push this, it
You have
moves.
to dumb it down for us. Some of us, not all of us.
Your dinner conversations must be fascinating.
Miranda and I like to argue. We like to argue about what came first, physics or engineering.
That's good.
It's like obviously it's physics because you don't have to study physics for it to be a thing. And she was like, well, people built buildings before they studied physics, and I was like,
God built the earth.
She might have you there.
God's a physicist.
We had y'all back just to argue the point.
I'm surprised to hear that gravity is a theory.
Yeah.
I mean, I thought that was very provable.
It is provable in the sense of our Earth scale, but there's like 2 types of gravity people use in science. Gravity on Earth is 9.81 meters per second squared. It's always pulling us down. That's pretty much set. You go outside of the Earth, the force that attracts suns and planets and stars to each other is gravity, and that formula has a gravitational constant, and it's the constant times the mass of the first object times the mass of the second object over the distance between them squared. And that's the formula we use. And I don't exactly know where the theory part comes in. I think it has to do with like black holes and antimatter and things that don't behave under gravity's laws.
Okay.
So we have to make adjustments. It's
All
like
the Star
a
Trek
asterisk,
things.
yeah.
Yeah,
There's like
hey, there you go.
It's like gravity.
followed on that right
This,
now.
it's like there's an asterisk that says this works 99.9% of the time, but in the event of you entering a black hole, your calculations may be off.
I guess
Or a hard
Newton's
Monday.
gravitation works in our solar system,
Yeah.
but not in general. So that's what Einstein generalized, right?
Yeah. I mean, Einstein's big thing was relativity. When light gets moving very fast, is light the true speed limit of the universe? Stuff like that. If you were able to move fast enough, you would slow down time. But in order to move that fast, you would have to have 0 or close to 0 mass, because light is massless, and it's as fast as anything can travel.
It's massless. Oh.
We consider distances in space in light years, like Buzz. Light years are just the distance a light particle will travel in the span of an Earth year. It's a light year, and it's very, very far. I don't know the exact number off my head.
What'd you say again? Like when you get to the end of a problem, or I'm paraphrasing, you find God. Can you say that?
Mm-hmm. It's Heisenberg,
Yeah.
Werner Heisenberg. The exact quote, let me read it. "The first gulp from the glass of natural sciences will turn you into an atheist. But at the bottom of the glass, God is waiting for you."
So good.
It's Werner Heisenberg, the winner of the 1932 Nobel Prize in Physics for the creation of quantum mechanics.
And when you did this a couple Mondays ago, when you got to the end
That's
of
awesome.
this theory, it was the habitable lifespan,
Mm-hmm.
the 80 million years. And that's what like sold me. It's funny that I just kind of paired that together. I'm like, well, there's God, right?
Yeah.
Because that's literally impossible. Yeah, all the explosions, everything happens. So something blasts the Earth, forms the moon, and tilts the Earth. I mean,
Yeah.
all this stuff coming together, but nothing can happen for 80 million years,
Mhm.
right? no disaster, nothing.
Nothing that will set
no
it back.
Katrina. Yeah.
Nothing
Yeah,
that'll.
at that point, there
No
has to
idea,
be a
yeah.
creator,
Yeah.
right?
Yeah.
I think so.
Well, we believe so.
I believe so.
Wow.
So I don't know how long does class normally go.
We have to talk for 4 more
I don't
minutes.
know. You got 4 minutes.
Or pray.
Any other questions? I just didn't want to. I didn't want to be like holding y'all here and like he was supposed to end 20 minutes ago.
I have to wait my wife. She's inquiring. Keep going, man.
No, this was great, thank you.
You know what?
One little, you mentioned that there's a spectrum of belief within
Mhm.
physics or in sciences in general. And some people, maybe on the atheist end, most, I don't know, Christians as well. If you were to give a talk like this to a group of peers,
Mhm.
what would be the reaction, or how would they?
Well, they wouldn't really care. It's not their field of study.
Yeah.
You would be stepping on like theological or
No,
atheological toes.
I've sat in our office during our coffee hour that lasts like 40 minutes or whatever, and we've sat and talked for multiple hours just about the idea of a God, a creator, or not. We very quickly move off of science into philosophical
And
debates.
that's okay.
Yeah, I mean they love people. I shouldn't generalize. The people I work with like having these conversations. It's fun because they like picking each other's brains.
You're in a whole different group than the people I used to work with.
No one like if they all know I'm Christian. They know our advisor is Christian. Everyone's okay with it. No one is like insulted, at least in my school, in my department, at the idea of Christianity. They're more interested to be like, so why do you believe that? And then we talk about it.
That's an openness. Mine wouldn't have been just insulted, they would have been enraged. I mean, a few would have been curious,
Yeah.
would have engaged you, but.
Yep.
The philosophical side that you can run numbers all day long, that I like to bring up in the debates is there has to be absolute morality. Because if there's not an absolute morality, then morality is defined by whoever's in charge.
Right.
You all feel guilty about certain things in your life, not because someone told you should feel guilty about it, but because you have a guilt implanted in you, like it says in the Bible, from God. If you would believe that there's no absolute morality, there's no truly good, right, or wrong, it's just whatever's best for everybody, then you believe that whoever's in charge and sets the rules defines morality.
Like our government now.
Exactly.
Yeah.
Whatever the law, that is what's right.
That's true.
But if you do believe in a creator, you have to believe that there is an absolute good and an absolute wrong. So no one ever really has a proper reply for that. They just say, well, I know it's wrong. It's like, well, how do you know it's wrong? It's like, because it makes...
All my
That's
kids have
interesting.
been teenagers, but it didn't sound that eloquent.
Well, we came here for a science discussion and it ended up being apologetics 101, right?
Yeah.
I apologize. There's not a whole lot of Bible verses or any for that matter that I put in.
We know all
unless
this anyway.
unless you want to just read the first chapter of Genesis.
We just got through that.
Yeah.
That's the creation story. So
And the heavens declare the glory of God.
We're studying for a long time to figure out that first chapter.
Well, thanks again, Adam.
Of course.
Thank you.
I
Thanks for
appreciate
having
it.
me.
Somebody's